Good afternoon, ladies and gentlemen. Thank you very much for joining us for this IMechE event. My name is Andrew Fraser. I'm the chairman of the IMechE Automobile Division, and it's my pleasure to be your host for this event today. And in terms of the IMechE, however, friend and colleague Steve Cropley has very kindly offered to lead this very timely discussion on the different aspects of transport energy provision between hydrogen and electricity, and how can the two possibly interplay in the new world. So without further ado, I'd like to hand over to Steve and welcome you to today's discussion. Thank you.
Thank you very much, Andrew. Welcome, everybody. Thank you for joining us. Our discussion, the one-line headline we've put on it is how hydrogen can fit the electric landscape. It's quite clear that as we move towards a low carbon propulsion, hydrogen and battery power seem to be predominating in everybody's discussion. And there is a bit of a tendency, I think, for people to regard this these two positions as being some kind of a war, as if you can love hydrogen and not love EVs, that sort of thing. Also, we hear that car companies are losing interest in hydrogen fuel cells, recent thread, but that's not the full story. The war is not the full story, and the other thing we hear is that EVs are booming, but there's a problem with range and a problem with infrastructure, and that isn't the full story either. So what we have here is a trio of experts who can put us in the right position on all of these things. First of all, we have Tom Callow, who's the face of BP as provider of electric power, which is a fascinating development for an oil company. We have Professor Dave Greenwood, who's from Warwick Manufacturing Group, who's working at top speed to improve batteries and commercialize them. And we have Tim Burnhope, who's the Director of Innovation at JCB, who's got experience in all these things. He has worked extensively with hydrogen, with EVs, and with electric power, on diggers and heavy machinery, and has actually led a team to build a hydrogen-powered piston engine. So I think with those people on hand, we can attack the problems and see what we think. Tom, I thought I would start with you because you're so good at summarizing the sort of situation for EV ownership at the moment. Tell us your view on these two popular conceptions that EVs are booming, but there's a problem with range and there isn't enough infrastructure. Just before you get going, I should say that the SMMT has been castigating the government recently for not helping enough with infrastructure. So they believe there's a problem. Do you?
We're pretty positive, as you can imagine. So BP Pulse, with a sort of EV charging arm of BP, we're pretty positive about the opportunity that EV charging presents and actually what's happening with the infrastructure landscape. One of the things, as you rightly called out, Steve, is that there is a sort of a view that government should be stepping in and doing more. But actually, this is going to be a private sector-led transition from an infrastructure perspective, and very much already is. So you've had millions and millions of pounds spent on EV charging infrastructure to date. We've got around 50,000 charging points across the UK, public charging points. We've got 5,000, 6,000 rapid chargers, for example, as well. But there are billions of pounds of private sector investment lined up, ready to be spent over the next decade. We know that, it's been various companies have announced their intentions, and I think there's a real positivity around what the pace of expansion will be over the coming years. So we've already seen a huge rollout of infrastructure. Just over 10 years ago, 100 miles of range would have taken you about 10 hours to get into an electric car, if any electric car could actually do that. Whereas today it can be less than 10 minutes. So you've gone from a sort of a factor of 10 hours to 10 minutes in less than a decade. And actually, we've got the sort of 8-year period to 2030 now, where I think it's going to be fascinating to see how much changes between now and then. So in terms of the infrastructure, I think a lot of it is around perception that you have to take hours to charge, perception there isn't enough. And a lot of that is actually not true. Of course, there are some challenges that remain. And I think in terms of the range as well, now we know that the average journey in the UK is sub 30 miles. We know 99% of car journeys are less than 100 miles. So if the average electric car on the market today can do 150 or 200 miles of range, that really is already quite sufficient. And we're probably getting to a point where consumers are starting to look at what they really need rather than what they think they need. But that's our view on EVs. Certainly very positive, but also not absolutist, as you said, Steve. So it's not about one technology fits all. We absolutely are all, I think we're all on the call, certainly sort of pro decarbonisation and trying to look at the ways to do that.
You're surely the thing that dogs all of us. I'm driven a lot of EV over the last few years, and the thing that concerns me always is going on holiday in Scotland, and the problem for me is the lack of infrastructure on motorways. That's surely the soft point, isn't it?
So yeah, we've seen a real issue with motorway charging, unfortunately, over the last 5 to 6 years. So for various reasons, there was sort of effectively a period where we didn't really see any investment in the growth of EV charging on motorways for about 5 or 6 years. The sort of contracts for charging at motorway services were effectively locked in to exclusive arrangements with one provider. It didn't allow the full private sector sort of investment to be attracted in and grow the networks there. But that's changing, hopefully. We've already seen some of the charging points upgraded. We're very much hoping that that things change in terms of the investment case at motorway service areas. And obviously, I should say there's a Competition and Markets Authority investigation ongoing in that domain at the moment. So we wait and see what outcome comes from that.
Is the business of actually providing the sort of utility support is a problem, isn't it? How are they doing with that?
So in terms of, I guess you're talking about the power infrastructure really around it. And obviously you've got two things to consider. You've got the generation capacity, the transmission capacity, and then distribution locally. We're certainly of the view and agreed on that with National Grid on this point, that up to 2050, we don't think there's going to be a challenge on the sort of transmission side. We've already reduced electricity consumption massively in the UK over the last 15 years. So if you rewind to 2005, we were using about 80 terawatt hours per year more electricity than we do today, or 77 terawatt hours per year. That won't mean much to people unless you know about electricity. But the Committee on Climate Change thinks that we might only need 65 terawatt hours extra to power all the electric vehicles in 2050. So it's possible we've already sort of netted that out in 15 years of energy efficiency since 2005. So in terms of the electricity available as a whole, we don't think there's going to be a huge challenge there. Where the investment's coming, and this is where the distribution networks, so the people that sort of distribute energy locally around your area, come in, is there's going to be big investment over the next sort of 5-6 years to basically upgrade various parts of the local energy distribution to handle electric vehicles, and also other things coming on stream in that timeline, such as things like the electrification of heat, as you see things like more and more heat pumps installed in homes rather than gas boilers.
Excellent. Dave, you're right in the middle of an area that is also going to help me with my trip to the top of Scotland. Tell us about the progress of, shocking journalist question, but tell us about the progress of batteries. The thing I'm aware of, for instance, is that a Nissan Leaf 10 years ago had half the range that it has now. What's the trajectory? Tell us about that.
Yeah, so let me take it in two directions. First of all, there is what the battery is capable of doing for us. And then secondly, there is what do we actually need from the battery? And those two things are both moving. And actually, the infrastructure question that you just covered is a big part of that. So before we look at where the batteries themselves are going, because they are getting better and they are getting cheaper, let's just think about what the trajectory is now with the technologies we have in front of us. And that is that today, because the infrastructure historically wasn't great, if you wanted to buy an electric vehicle, you needed a lot of range. So if you look at the Tesla model, when they first brought out their vehicles, the key to unlocking the market was delivering vehicles with big range to get over the fact the charging infrastructure wasn't great. And they're expensive vehicles, but there's a demographic that could afford it. What we can see now is that as the charging infrastructure is starting to roll out, or as it has rolled out, particularly fast charging at motorway services, the thing you talked about earlier on, you move to a world where you don't need the car to be able to do 200 to 300 miles of real world range anymore. The car's able to do something like 150 miles of real world range as long as you can reliably fast charge it at a motorway services in order to be able to continue your journey. So actually, one of the things is, you've seen this trajectory of the range of vehicles going higher and higher for a while. What you're starting to see now is actually it's starting to come back down again, or at least you're starting to see a bifurcation of products. There's a premium range of products which are continuing to have very long range for customer convenience, but they come at a price because they need a big battery to do that. But you've also got a range of vehicles now which are starting to address this problem of cost by moving to a smaller battery, which is capable of fast charging, which does all of the commuting stuff that you'd want to do, and that you can then fast charge at a motorway service station in 30 minutes or 20 minutes to be able to do that. So there's these two things going on. So batteries, loosely speaking, batteries have come down in price in the last decade by a factor of 10. And they will continue to come down again by probably a factor of 2 in the next decade. And they've doubled in terms of the capacity, the amount of range we can fit into the vehicle in that same period. That will probably not continue increasing at quite the same rate, but it is going to get better. So you'll probably get another 30%, 40% capacity into the vehicle in the next decade as well.
That's really interesting. There was a thread just a day or two ago in the press about how the battery chemistry seems to be dividing, and there was suddenly talk of performance car batteries and ordinary car batteries. What's that about? Does that have a connection with solid state batteries, which I also would like you to offer on?
Yeah, it absolutely does, and it's that same split that I talked about in terms of the product. So if you're going to make a car that's relatively low cost and relatively low range, I say relatively low, 150 miles-ish real world range, you don't need the ultimate best expensive chemistry that's out there. You can do it with something that's cheaper. So you can typically answer those kinds of questions with chemistries like lithium iron phosphate, which don't contain cobalt, they don't contain nickel. They're much lower cost batteries typically to produce. And because you don't need lots of range, you can put up with the fact that the battery is going to be a little bit bigger per kilowatt hour because it still fits within the vehicle. If, on the other hand, you're targeting that real long range application, so typically your premium passenger car, you are still really nibbling away at the benefits you can get on energy density and power density. And that's really what's pushing you up at the moment to the very high nickel materials like nickel, cobalt, manganese. And later on, that's the market that will be the place that solid state starts to fit in. They're more expensive on a pounds per mile basis than the ones that you put into the lower cost, lower range vehicles.
So it isn't the case that we'll just all move to solid state batteries when they're available. There'll always be batteries with different duty for different roles.
It's going to be very like looking at the way that engines are used in cars today. Not everybody puts a supercharged V8 in their car. Not everybody can put a 600cc two-cylinder engine in their car. Different vehicles use different engines because of their different duty cycles and because of the buying priorities of their buyers. And you're going to start to see that increasingly become the case with batteries now that we have got to this position that the charging infrastructure is starting to unlock the range challenge.
Just getting onto the hydrogen theme a little bit. You're very firmly a battery man, clearly, or known for it, let's say. But do you have a comment on this perception that you're either a hydrogen type or an EV type?
Yeah, so I wouldn't describe, well, obviously a lot of what I do is in batteries, but I wouldn't say that I'm a polemic and pro-battery, anti-hydrogen person. That's absolutely not the case. Batteries are brilliant in some applications, but frankly, they're not going to answer all of the questions that we've got. It's going to be extremely difficult to see how something like a 40-ton truck or an aircraft would ever get to the kind of energy density and power density that batteries are able to deliver, solid state or otherwise. We just run out of periodic table before you get to the kind of energy density and power density that those things need. And so we will still need zero carbon alternatives for those platforms. And maybe it's hydrogen, maybe it's not. There are some other things out there. People are looking at ammonia. There's all kinds of other energy vectors, but certainly, hydrogen and hydrogen fuel cells and hydrogen internal combustion engines are definitely worth looking at in those applications where batteries just aren't economic or can't deliver.
Oh, I see. Tim, you're right in there. You've done it all, haven't you? You obviously, clearly, your mission is to power heavy vehicles, off-road usually. Can you summarize the various directions that you've gone in, and then we'll ask you a bit about your hydrogen engine as we go on.
Thanks, Steve. Just to give some background, we started probably around 5 years ago, and thanks very much to Professor David who helped us understand what a battery was and how it should be used and how it should be employed. So we worked very closely with Warwick in the very early days, and today we have 7 electric products available on the market, and there's seven different types of products. So there's a small compact excavator. We have 2 types of forklift, one an industrial forklift and one a telescopic forklift for off-road. We've got 2 types of dumpers. We've got a scissor lift. We've even created a battery box, a bit like you have with your phone. So if your piece of construction equipment runs out of charge, we can charge on the move if it's there. Now, we started with our small compact equipment because going back to what Tom said, really looking at car technology to start with and what was available from cars. And again, our small equipment tends to be like a car. So if you think a car does 12,000 miles a year, average of 40 miles an hour, it does around 200 or 300 hours a year. And our small compact equipment is pretty much the same power demand as a car. So 1, 2, 3 hours if you're lucky at full power in a day, even though it'll work a full shift. So we started to study it, and we've employed that technology. We sell the machines all around the world. We've sold to 23 different countries. So we're very proud of the work we've done on electric. I guess we were maybe a bit naive in the early days where we thought, well, okay, we've cracked batteries on small machines. We just need to get bigger now. We just need to keep adding batteries, adding. But I think we started to realize that becomes a kind of a tipping point, as we call it. And what we realized is we suddenly go from, I guess if you think about a car, you suddenly go from the person that does 20 minutes in the morning and 20 minutes in the evening to somebody that wants to drive a car for 12, 14 hours a day. And it suddenly jumps to your Amazon delivery van or whatever that may be. But all of a sudden, you have to start and consider the number of hours that the product needs to be used. We're also very conscious that because electric products are more expensive, in our case around 70% more expensive than a traditional product, then a customer needs to be able to work that longer to get the payback. You know, the price of moving a ton of earth doesn't suddenly go up 70% as a consequence of fitting batteries. So ours are work tools at the end of the day, and we have to make sure that they're very competitive for our customers. So, cut a long story short, we started to look at all of a sudden when we have an energy jump. So when a machine's not doing 2,000 hours, say it's doing 3,000 or 5,000 hours a year, we can't suddenly multiply the number of batteries by 10 times. We can technically. I mean, anything is technically possible, but commercially it wasn't right. The other thing we're very conscious of is to allow Tom's goal of many millions of charging points to be put in place over the coming years. Our machines will be the ones that will be digging those trenches to put those cables in safely, and we'll be there first. So our dilemma is that we're there and we need to put the charging station cables in, but we can't charge it because the charging station's not there. So the small electric machines today are sold as urban maintenance machines where the charging stations would be available. However, when we're more remote and we're putting electricity in for the first time, or we're connecting to cables for large offshore wind turbines, or we're helping out to install solar panels, the electricity is not there. And the challenge for us is the majority of our machines, 75% of the machines that we make, we deliver fuel to the machines. The machines don't go to the fuel stations like you would with a truck or any other product. So we desperately needed to look at a mobile fuel, and naturally that first mobile fuel that we looked at was hydrogen. So we moved on to look at fuel cells, and again 3 or 4 years ago, maybe 5 years ago, we talked to fuel cell manufacturers, but they were very focused on the car world, and our volumes were too small, and the size of fuel cell we wanted was a little larger. So we did experiment with a small fuel cell complemented by lots of batteries, a bit sort of a hybrid fuel cell if you like, and started to gain experience of hydrogen. We knew that was inappropriate, and then a few years later fuel cell companies came back and said, we've now got a prototype for you. We'd like you to try it. It's larger capacity. And we're interested in your volumes now. And I mean, you can make your own conclusion from that maybe they hadn't taken off in the car world. So we got a full-size fuel cell. We did it on a big 20-ton excavator, a machine that weighs 20 tons. And we put that to work. And we found one or two challenges. So we found that, you know, fuel cells, those membranes are a bit like windows. They don't particularly like dust. So we do work in dusty environments. We do work in environments with harsh vibration, which again is part of the learning. We didn't realize that you have to cool machines. So we need a cooling pack that's 2.5 times the size of a typical engine. So again, physical location of a large cooling pack is a challenge. We also didn't understand things like the coolant, that they needed to be deionized. So again, in our world, if we lose a coolant hose, we'll pretty much try and get some form of water from anywhere to keep that machine going. But the fact that you need something special doesn't necessarily help us, especially when we're digging infrastructure in Africa or India or some of those new areas where we're seeing massive urbanization growth. So we learned a lot. But the biggest issue for us was our customers have said for years, we can pretty much design any piece of construction equipment or agricultural equipment that we want, but don't make it too complicated and too expensive for the market it serves. I think it's fair to say our fuel cell excavator was definitely too expensive. So we would sell that machine today for around £120,000. And the fuel cell prototype we used was 98,000. The DC-DC converters, 28,000. The very special battery pack that we put in that was lithium titanate, where even though it was only less than 10 kilowatts, was probably another 25,000 to give this massive power and transient response that we needed. So by the time we summarized all of that and we looked at all of the complexities of the fuel cells, then we ended up with a product that would be at least 2.5 times, if not 3 times more expensive, and just too complicated for our market to serve. So we were really attracted to hydrogen because it's a mobile fuel and we can refuel in 7 or 8 minutes, exactly the same time we do with the current fuel. So they are very, very attractive. But sadly, we concluded that the fuel cell at this time is not appropriate for the environment it needs to serve. So as we sat down to look at our strategy, you know, we're very focused on net zero. We're very passionate about getting to net zero as fast as we can. So we've got small electric, and then all of a sudden we're in shock because we can't make a fuel cell work on a big product. So we took time out and we started a way up. Well, should we go battery? Let's look at batteries again. Let's try and work out how we can get more and more batteries. When do we get double the range? When do we get triple the range? You know, if you think about it, Steve, our work environment is like you being on holiday in Scotland all the time. You know, it's constantly random. You're constantly moving. A lot of the work is unplanned. So we kept saying we definitely need to use hydrogen. We need the mobile fuel. We need to allow machines to work 20 hours a day on a double shift if necessary on a site. So we started to conclude, well, why not look at hydrogen combustion? And we looked at lots of the experiments of the past. They'd been done a lot in the late 90s, and then people had kind of gone off them to look at more tailpipe emissions. We researched about 76 projects, I think, and understood what the challenges were. We found there were 11 issues, probably going back to 4 root causes. And over the last 18 months, we've been working on those. And now we're looking very actively at a hydrogen combustion solution, complete net zero in terms of carbon, and looking at that potentially in all different forms. And what we do with that and how we align it with other technologies. But I think we firmly believe for the grunt, as we call it, that David said a few minutes ago, like we are like a plane, we are like a big truck, we are like a train that needs massive transient response, and really that hydrogen combustion solution for us is perfect to complement in that environment.
So tell us exactly what you had, because you've built an engine, haven't you, or some engines, and done it in massively short time, haven't you?
Yeah, so you can imagine when we were presenting to our, you know, we're still a family business run by Lord Bamford. And when we presented the findings to Lord Bamford about what we could do with electric and what we couldn't do with fuel cells, and we said we'd like to have a go at hydrogen combustion, he said, "Well, I'm not sure you can make it work, but you've got 6 months to have a go." So back in the middle of the pandemic, almost, we I think in July of 2020 we presented that, and then by December 2020 we had our first product running, and we've gone through multiple prototypes now, different variants, where we've refined it, and now we're making great progress. We've got I think 3 machines now operational that we're testing and evaluating and recording all the data. Obviously, engines on test cells. So we're pleasantly surprised how fantastic it is, where you can take or use 70% of the existing parts from a traditional supply chain, and then you've got to redevelop that whole new, what I would call as a high performance gas ignition solution to make it work.
Can you tell us a bit about how it's fueled? Is it you know, there's a great big tank right next to the or on site, isn't there? How does the fuel get there? How's it produced, and so on?
So today the fuel either comes from an electrolyzer, and I think we're all aware yet that the transition, like most of the energy sector, there's byproducts of hydrogen potentially produced from chlorine that can be delivered. Some will be made from gas, I guess, in the short term, and then everybody wants green hydrogen, renewable, as we move forward. Once that's produced, it can be shipped. Today, it's shipped in tube trailers at relatively low pressure, but we want to see that increase in pressure so we can transport more per load. And then we pretty much take that to a refueler on site, where we can decant based on pressure. And then we run it, unlike the cars that run at 700 bar, we're running at 350 bar to allow us to decant gases. But again, that supply chain for hydrogen exists today. You know, you can ring BOC or Air Liquide or RISE or a number of companies and have hydrogen supplied. Again, the future will all be about the quantity that can be supplied.
What do you reckon is the solution for vehicles that have to move? You know, but we seem to have a way of having the cars we want in the future, and a way of having the diggers we want in the future. But what's going to be the solution for HGVs? Because I can't see one.
Well, I think the big challenge is different countries, I think, have different ideas on that. So I think Scandinavia is attracted to overhead cables. Germany, I think, is very strong into hydrogen in both fuel cell at the moment experiments and in hydrogen combustion as well. And then also you've got maybe the UK that's more focused on the thought of using batteries. So I think it's all very mixed. I think one of the challenges in the truck world is they're so focused, I think, on Euro 7 in 2026, 2027, that they haven't really got the opportunity to do the level of experimentation. We're pretty lucky where we've gone off and we've experimented with each type of technology to work out what really works for our industry. And I think the truck world needs to go through that. The train world needs to go through that. And definitely the aircraft industry needs to go through that as well.
Tom, I know you know, hydrogen wasn't your specialist subject, but presumably, I mean, you work for a refueler. You know, presumably BP is going to have some sort of a strategy in the future for the HGVs that lob on the forecourt, aren't they?
Absolutely, and BP announced recently with Daimler, you know, plans to invest in hydrogen refueling infrastructure for trucks, heavy trucks. I think from our perspective, the landscape for heavier vehicles is probably going to be mixed with various energy vectors. There probably will be battery electric trucks of various shapes and sizes, particularly kind of you know, maybe sort of rigid 7.5 ton, that kind of thing. And there will be hydrogen powered trucks. That's pretty clear to us. There'll be a mixture. I think where there is a little bit more consensus now, and you saw the comments from you know, people at Toyota Motor Europe about their view that only a few thousand hydrogen passenger cars would be sold in you know, 2030, 2040, despite being the kind of champion of a hydrogen passenger car. I think there is this consensus now that passenger cars, particularly in other sort of light duty vehicles, are predominantly going to be battery powered, and a lot of it just comes down to economics. That actually the economics are in favour of battery electric versus hydrogen fuel cells, particularly on the infrastructure side. But we certainly aren't absolutists, as I say, and I think the point I'm always keen to sort of highlight is that you do tend to get sort of a lot of absolutism in this space, and people being very sort of adamant about their views, and particularly where maybe people have bought pure electric cars, or sort of you sometimes get a quite sort of anti sort of oil and gas sentiment or anti-diesel sentiment. But the reality is that I suspect everyone who drives an electric car today, including myself, got that electric car delivered to them in some way involving diesel. It probably either came on a diesel-powered ship, or it arrived on a diesel-powered car transporter or something like that. So we have to use various energy vectors to sort of live and work today, and we expect to continue for a long time. Not everything is going to go pure electric overnight.
Yeah, I see. What
Steve,
do you reckon?
Steve, we got a number of questions coming in. When do you want to take these?
Well, let's attack a few.
Okay, so I'm going to group some of these. First of all, on the hydrogen side, some people are saying creating hydrogen uses quite a lot of carbon. I don't who's best. Probably Dave, maybe best to talk about that. And burning hydrogen creates NOx. I don't know that personally, but again, if somebody could answer those.
Interesting to hear Tim on the exhaust emissions. Yeah.
Yeah.
What Dave? Why don't you start, and then we'll ask Tim to continue.
Yeah, certainly. So in terms of creation of hydrogen, obviously there's lots of different routes that you can take it. In the worst case, you can go from particularly dirty hydrocarbons, things like coal, and produce it. That's not the way we want to go, because you would produce a lot of carbon in the process of doing that. Commercially speaking, an awful lot of what's on the market today comes from natural gas, so it does have CO2 attached to it. But the trend is definitely towards renewable hydrogen, generated either from renewable electricity or from renewable biomass, or from industrial byproducts. So the carbon intensity side of hydrogen production is expected to reduce over time. But that's not actually the full story, because the other part of it is looking at the energy efficiency, excuse me, the amount of energy it takes to create enough energy in hydrogen to be able to power a vehicle for a certain distance. And one of the challenges that we have is that there's lots of steps you have to go through to make hydrogen from renewable electricity. So let's say you start with a wind farm, you run it through an electrolyzer, you pressurize it, you transport it, you repressurize it as you put it into a tank in the vehicle. Then it goes into a fuel cell, which only has about 40% conversion efficiency. Then it goes into a motor at about 80%. Anyway, the bottom line is you start of the 100% of renewable electricity you started with, if you're really lucky, about 20% ends up at the wheels, and the other 80% goes as heat to the atmosphere at some point. If you go with a pure electric solution, it's the other way around. Roughly 70% of what you started with finishes up at the wheels of the vehicles, and about 30% comes out to the atmosphere. So where you can realistically put electric in order to do what you want, it's much more energy efficient, which means that you've got to put less energy generation capacity in place, fewer wind turbines, lower cost, all of those kinds of things. But there are situations where you just can't electrify in that way. So the JCB products, the bigger JCB products, are a perfect example of that. And actually heavy duty vehicles are an example of that as well. And in those situations, you've got to weigh up where are you going to take the compromise? Is it going to be on the energy efficiency, in which case you'd go in a hydrogen direction, or there are some other methods that you could follow which should take you differently? So broadly speaking, I'd say the CO2 intensity of hydrogen, yes, there is carbon in it, as there is in electricity today. Electric vehicles have exactly the same challenge. We generate our electricity from a mix of renewable and non-renewable sources today, and that's improving. Actually, hydrogen's in a similar situation, but the thing that is different because of the physics is the energy efficiency of getting hydrogen power to the road versus taking electricity to the road.
Yeah, well, so nothing's perfect, is it? It's annoying. Tim, could you talk about the emissions issues with the hydrogen engine?
Yeah, I just if I can, Steve, as well, I'd just like to pick up on the last point.
Yeah, please do.
And again, it's very dependent on the application. So we have sold, for example, forklifts into distribution centres for some time. And those electric ones, even though they would be all technology batteries, if you bought, say you needed 100 forklifts to run your distribution center, you would have to buy 200. So you would have 100 working for 12 hours, and the other 100 will be on charge for 12 hours. Now, thankfully, the battery technology has improved, but again, in our industry, where you want to work long hours, you must also take into account the equation of efficiency is also about the ability not to use the product during the time it's charged. And that for us is if you take that old-fashioned scenario, and it's improved, but that's a 50% inefficiency of being parked up. Now, that's not the same with a car on a small range where you can get all those benefits, but that there are challenges. If you think about a ship, you can't stop with a ship and charge it up. You can't stop with an aircraft and charge it up halfway in midair. So that there are areas where the product needs to keep working, and that ability and therefore that efficiency to keep it running should be brought into some of the calculations. And I think exactly from the learning from Dave and I over the years, that this is where the technologies, and we all want to compare to electricity, but we're not there yet. We've never ever achieved those levels of efficiency, and there's going to be a transition for 30 years to get there in some form.
Yeah.
And I think we should do some of the comparisons to what the efficiency levels are today. So for example, our product range, we've made all of our products 50% more efficient over the last decade to prepare for using less batteries and to prepare for using less hydrogen. So there's a lot of work that needs to be done on the base product to make them super efficient, to allow them to use those different technologies. Moving on to the NOx one, and that's really the interesting one and the exciting one. So for many years, people did, we looked at 76 experiments, and to be fair, there were probably 76 conversions. So they'd basically taken the majority, I think 90% of them would be spark ignition engines, and literally just put hydrogen through. Many were done in the 90s when turbo technology, for example, wasn't great. So there were large capacity engines with not a great deal of airflow. But anybody that knows the NOx equation really well will understand if you can go away from, so we, like anybody, has spent years and years developing high temperature, very, very high pressure combustion. The downside of that has been NOx, and we've treated that with after treatment for many years. In fact, in 20 years and hundreds of millions of pounds worth of investment, we took an engine and we eliminated, or we got down to about 90, just short of 99% reduction in NOx over a 20-year period. So the engines we're producing today are incredibly clean in terms of that. Now, you then move to a low temperature, low pressure combustion cycle. And again, if you can work at low temperature, then the clever part is that you pretty much eliminate the generation of NOx in the first place. And then whatever very small amounts you may pass through for whatever reason of blips in combustion, then you can use an after treatment to tidy that up. So I think one of the problems is we all read, and we did as well. We'd concluded 5 years ago we could never use hydrogen combustion because it created NOx. And one day we just said to ourselves, we can't use a fuel cell. So we got to find some solution. And I think as engineers, and there are many engineers on this call, what I would say is technology moves on, and as technology moves on, we never had this level of sophisticated after treatment before. We never ever had sophisticated turbos where we could completely change the air to fuel ratio. And the one thing that we've all now got that these people didn't have 20 years ago was just fantastic CFD models. So we can start to model all of this, and getting help from universities. We're working with the University of Aachen in Germany because they've got the most sophisticated modeling in this area. And we modeled and modeled and modeled. And I think we're up to our 160th iteration, and these iterations aren't simple. They're massive calculations, but we've refined and refined and refined using modeling techniques to make sure that we can understand what that perfect combustion process is to produce not a converted solution, but to go back to the basics and create the most perfect high power hydrogen fuel motor.
Gotcha.
And I think that's for us is what you've got to think about. Don't get carried away with what you read about products from before. You have to create the new product that avoids the carbon and avoids the NOx.
When you did this, was it a big surprise to you that this was possible then, or was there just a day when you suddenly thought, wow, we can really do this? Did it come to you through modelling? I suppose it.
Yeah, I mean, we modelled and modelled, and I think one of the articles we found was I think it was a Russian scientist who'd been looking at the temperature range of where NOx is actually produced in any form of combustion process, and it was amazing to say that he basically gave temperatures and it plotted over time just that graph. But actually, that was way back in the early 1900s, I think. And then we forget, I think the first combustion engine that was ever run on hydrogen. I'm trying to think of the date. 1776, I think, was the first.
Really? Gas engine.
So we think it's something new, but if we just been perfecting it for pretty much the last 200 years, we probably would have got there a lot quicker.
Two questions. How widely can this spread? I mean, clearly your preoccupation is diggers, but one of the points that Lord Bamford makes, I think, is that if this spread more widely, the existing supply chain could stay intact, or large parts of it, and he feels that EVs and modern engines tend to be inflationary, and if you stick with pistons in some way, perhaps that quells inflation as well. So one wonders, could this engine go into trucks? Could it go into big cars even? What's the potential?
Well, I think there's real excitement that it could definitely get into the truck world. I think it should definitely be considered for the train world. Sometimes we forget that trains last years and years, and many trains have engines, replaced. So there's maybe an opportunity to get to net zero quicker by using replacement solutions. And I think that's the part that we've all got to. I think there's probably a belief that with people like Tom driving it and David driving it, that on the passenger car side there is an opportunity to get there. We mustn't forget that technology started for us at the small energy and the small hour usage level. Much of industry is at the other end of the spectrum, and I think we need to just be very, very open-minded where those different solutions can work.
Yeah.
Mr. Toyota is an advocate of hybrid solutions, and I think we've all got to be much more open-minded that it's not bad to have a hybrid. Let's use hybrids for the next 10 years. They're electric products. Okay. You've got a range extender, but if that's more affordable in the short term to get people into electric cars, then we should think about that. So yeah. I think Toyota said that is it their hybrid cars spend 60% of the time, which is most of the city driving, on the battery side. Mr. Toyota has bravely started to talk about hydrogen combustion and has got one in a car, and I think we'll see more of that in Europe shortly. So there are parts of the world, it's not just all about Britain and all about Europe. There are parts of the world where cars, are nowhere near the cost of what they are in the developed markets. And we've got to think about the likes of hydrogen combustion with a smaller number of batteries will allow us to transition to the solution in the longer term. So I think we've got to be very careful, and we've really got to think about the affordability, the ability to get this transaction to work, and what's involved in the steps to get there. And that's where our chairman comes from. Our mini excavator in diesel is £18,000. The electric version is 32,000. When we talk to customers that buy thousands, it's a big on cost.
Yeah.
They all want to use them, but there's a real nervousness of can I really afford to move to that technology? And I think for us, the beauty of the hydrogen combustion engine is that it's the exact same supply chain. We can move that supply chain very, very quickly. We can get going. We can get to zero carbon very, very quickly. And that allows others to use batteries. It allows gigafactories to be built. It allows the cost and the technology of batteries to move on. But I think we should all think about what the end game is.
Yeah.
We must keep thinking about the steps to get there.
Just talking cars, this is a sort of open question for anybody. But could you imagine a hydrogen, a hybrid car, a Toyota Prius with a hydrogen engine? I mean, why not?
Can I pick up on that one? So I think if you look at passenger cars, for the majority of passenger cars, battery electric, for a couple of reasons, is the direction it's going. And the reasons are, first of all, the trajectory for battery electric is getting a lot cheaper. And secondly, frankly, the car companies can only afford to make one massive energy, seismic technology shift in a product generation. So the idea that they could be, simultaneously doing hydrogen internal combustion engine, hydrogen fuel cell, battery electric, it costs billions for them to translate their power, their range, and they've made their bet, and they've put their bet into battery electric. So for passenger car, really, that is the way things will go, and it will work for all but the biggest and heaviest of passenger cars. It's a bit of a challenge when you look at the biggest SUVs to be able to give the kind of range that customers will expect. Maybe hydrogen could come in there. I think my guess is actually they'll bring the weight and drag down and reduce the energy consumption in exactly the way that Tim talked about for what they've done for diggers, and the battery trajectory will come up to meet it. So for passenger cars, I'm afraid I really don't think that hydrogen and fuel cell or hydrogen internal combustion is going to happen. However, for applications where fuel cells are being considered, so things like trains, like heavy duty vehicles, the hydrogen internal combustion engine is absolutely a valid competitor. The conversion efficiency of a fuel cell at best is about 45-48% if you hold it in exactly its sweet spot. A really good heavy duty engine is operating at those kinds of efficiencies at peak. So you could genuinely take out anything the way you see a fuel cell hybrid, because most fuel cells are hybrid. They almost always have a battery alongside them. Wherever you see that, you should seriously think about, does that need to be a fuel cell, or could it be a hydrogen in combustion engine? It's entirely possible.
Wow. Who might? I mean, JCB are clearly working on their own engine. Tim, one question I forgot to ask you is, when might we see this in production? But the other thing was, presumably somebody somewhere has to think about, there has to be a Ricardo or someone like that works away on these things and creates the technology that the OEMs, that the train manufacturers and the rest of them can plug into.
I think so. I think I think what's happened is everybody's got, because the car industry's gone first, then everybody's focus has been, even the supply base, everybody has decided that batteries are the solution. And actually, our greatest frustration, especially our chairman's frustration, is when people should talk about the banning of fossil fuels, they talk about the banning of combustion engines. The carbon issue is not the piece of metal's fault.
No,
it's the fossil fuel. We all know we've got to get rid of fossil fuels. Why not use this piece of metal technology to make a solution and get there much quicker? But more importantly, in an affordable way, where customers in the short term definitely, and for our industry probably the longer term, is to have something that's usable, that can be serviced, that can be looked after, in the same traditional ways. And I think there's just some learning there about the, don't underestimate the time to transition.
Yeah.
And I think David hit some good points with the challenge of fuel cells, and I think everybody thought fuel cells were the answer. I mean, just say if cars had been looking at hydrogen combustion hybrids 5 or 10 years ago, it might actually have been a very different answer for long range use. Whereas local people that do local distance could potentially use full battery solutions, but for people that are travelling, down to Cornwall for the holidays, or the usual 7-hour haul, then there's times where you can just complement. The other thing we shouldn't underestimate is the time of the challenge. I often think that, especially for the truck world, I think there's something like 8,000 fuel stations in the UK we model and use. So there's 8,000. You can put 8,000. It's much easier to put 8,000 hydrogen refuelers to help trucks in garages across the UK, truck depots, than it ever would be to put charging stations into every logistics centre. So again, when you work out the size of the charges, the capacity they need, a few years ago we looked at when Mr. Tesla came out with his electric truck and said, you can do a fast charge with this electric truck in 2 hours at a distribution centre. And we were all excited because we thought it's just like one of our machines. We should be able to do exactly the same. But then we worked out the equivalent power. It's something like 15,000 homes. It would wipe out our local town of Uttoxeter if we charged one vehicle up overnight. So we sometimes we're a bit naive to the size of the cables we need. This is a proper job of recreating the whole infrastructure. And I think we've got to get on and decide which bits we should do and get focused on that. Everybody says you can't use a wind turbine for hydrogen, but in the summer, all those wind turbines are being used, or the little bit of sunshine we get in the summer for solar panels. We can make hydrogen and we can store it for use in the winter. So there's if the two technologies work together, it's actually very, very complementary. So there are times when you just can't use the electricity that you're generating, and that'll be in the future when we've got potentially overcapacity. So let's make hydrogen, and therefore it does become more efficient because you're cleverly using it when you need to. So I think we've just got to think about how we complement, how we work together to get to the solution.
Yeah, we possibly need some quality politicians to help us with that, won't we?
Steve, rather than get into politics, we've got a couple of other questions that need an answer. One is, what are the plans for end of life management of batteries? Okay. And the other is, if a truck driver has to stop every 4 hours, that's 220 miles. What's wrong with batteries in a truck? Because the 220-mile range should be possible. Question.
Any thoughts?
So to start with the second, the end of life batteries piece. So this is an area where there's a huge amount of work going on at the moment. So obviously the batteries that we're putting into vehicles today will live on the road for 12 years, 15 years or thereabouts, but they're carrying an awful lot of expensive and important materials inside them. And we need to make sure, for a number of reasons, that those materials are first of all safely recovered at the end of their life, so we don't end up with batteries being disposed of illegally or unsafely. And there is legislation in place to force that. So the vehicle manufacturer is legally responsible for the safe and environmental disposal of the battery that's fitted into their vehicles. But we also need to make sure that we can recover those materials efficiently and put them back into the battery supply chain so that we're not having to mine more materials into the future. And we've been working on a bunch of projects. We're working with 3 different companies in the UK that are establishing full-scale battery recycling plants that will be able to take in end-of-life vehicle batteries, dismantle them to the point that they can then go into shredders. The shredders then recover take out the valuable materials, and then they go off for treatment to turn them back into the nickel, the cobalt, the manganese, the lithium, the expensive metals that come through. We do need to see the legislation catch up a bit. Right now, the battery directive, which is the law that governs the way in which those batteries are recycled, says that only 50% of the mass of the battery needs to be recovered. And that includes the big steel case that goes around the outside. So guess which the cheapest bit is to recover. And the problem we've got at the moment is actually there is a net cost to disposal of the battery. It costs money to strip it down, recover the materials. So actually, there's not an economic benefit for the recycler today. What we are seeing is that regulation is likely to be changed. If you look at the dialogue in the EU at the moment, they are proposing a much more stringent regulation that requires that a much higher proportion of the battery has to be reclaimed. It also says that if you've got certain valuable materials in the battery, then a certain proportion of those need to be reclaimed individually. And it also puts a requirement onto the new battery manufacturer to use a percentage of recyclate in their new batteries. So it actually puts this triple lock on the system to keep all the materials in the system and make sure that we get the carbon benefit and the cost benefit of recovering all those materials. So it is starting to happen. You're not seeing a lot of it right now because there aren't a lot of second end-of-life electric vehicles around right now. The companies we're working with are struggling to find feedstock for their plants because there aren't enough old electric vehicles dying. They're lasting much longer than everyone expected. And in fact, what a lot of these factories or these companies are looking at now is they're looking at the gigafactories and they're looking at the car manufacturers and they're looking at their waste streams as being some of the earliest feedstocks that they can take and get the plants up and running and make them work. So actually what you'll see is we grow the industry based on the manufacturing waste. And then obviously in a few years' time, 5 years' time or so, you'll see the volume of used batteries coming in and starting to fill that gap. And then a quick comment to the second question. So why isn't it a big issue for a truck driver to stop every 200 miles and refuel? Part of the challenge is that the size of the amount of energy that a 40-ton truck uses means that if you wanted to achieve a sensible refueling time, you're going to need chargers that are capable of pushing out a megawatt or a couple of megawatts a piece. And the electrical infrastructure that you'd have to put in place for that is just immense. If you look at the viable schemes that we're looking at from an analytical point of view for trucks in the UK, I really see three possible scenarios. Battery electric is not one of them. What I do see is if you want the lowest possible energy, the greenest possible solution, so low emissions and lowest energy, it's actually to run catenary cables. So have a pantograph on the truck, catenary cables down our motorway trunk network, of which there's around 2,000 miles in the UK. Cost about £2 billion to do that, which is a lot of money, but not compared to HS2. It would also need about the same amount of money spending on electricity generation. You'd need about an extra 2 gigawatts of generation on the grid, and you'd fit a small battery into the truck, about 100 kilowatt hours, which is enough to take the truck from its collection point to the trunk route, and from the trunk route to its collection point. And that actually gives you the lowest possible emissions and the lowest possible energy use. The problem is that to make it happen, you've got to simultaneously get the truck manufacturers, the infrastructure manufacturers, the electricity generators, and the distribution network operators to all agree that's the right answer and go away and do it in time. Because it's no use having 10 miles of electrified network. If you can only get a truck to go from 10 miles down the motorway, nobody's going to build a truck for that. So it takes a massive infrastructure provision. And that's why actually I think it's probably more likely that where we see a market-driven solution, which is what you're likely to see in the UK, things like hydrogen fuel cell or hydrogen internal combustion engine hybrid is much more likely to be the solution that plays out. And we just have to accept it's much less energy efficient. So we are going to have to put up 5 times as many wind turbines, but it gets you there quicker.
Wow, that's a mouthful. Paul, any other questions that the burning questions? Because I've got one more that I need to ask Tom just for my own edification before we finish.
No, give the time, Steve. You go for it, mate.
Tom, this is a sort of motorist question. Are we going to be happily equipped with enough infrastructure by 2030 for me to go on with the motoring behaviour that I've been used to all my life?
Our view is obviously, as you'd expect, yes. I mean, a few builds on that. I mean, one is, and just kind of coming back on some of the points in the chat. I mean, we're already much more standardized than we were in terms of things like connectors, right? So it's no, in terms of picking a right connector, it's a total myth that we've got some complexity in the market, really. It's no more difficult to plug your car into the right connector than it is to turn up at a forecourt and pick between the green pump and the black pump, right? It isn't more complicated than that, and anyone that says it is just doesn't understand the dynamics of it. In terms of the usage of them, again, we're a world away from this kind of, wallet full of plastic cards that you used to need to get around EV charging infrastructure 4, 5, 6 years ago. There's regulations already in place, all the sort of rapid ultra-fast chargers being rolled out of kind of contactless tap and pay terminals. In terms of the time to charge, we need to get away from the myth that, EVs aren't for long distance driving. You can, as has been proven by the Guinness World Record drive from Land's End to John O'Groats in a pure electric car, and your charging time on that journey of 800 plus miles could be 45 minutes. If you don't stop 45 minutes driving 800 miles, I don't want to be on the road near you when you're at the 700 odd mile mark, right? So, it's already possible to charge very fast and do long distances in EVs, and I'm one of the people that does that. I think, the ease of use will improve dramatically, not just the amount of infrastructure, but the speed. The key thing is I've got an ad in my room here from 1912 showing a General Electric home charger for an electric car, right? So electric cars with 100 miles of range have been around for more than 100 years. What hasn't is really fast charging. And that came along with things like the Nissan Leaf 10 or so years ago in the UK. So the fact that you can charge quickly is the game changer for me. That's the game changer that means you can actually drop an EV into your lifestyle. We're going to get away from the kind of, the need to kind of go onto a map to check if charging points are available. There will be enough infrastructure for you to just get in and drive and stop on your way as you would today. Nobody gets in their petrol diesel car today and says, "Oh, I wonder if the BP garage down the road is open today." We don't want to get consumers into that trap of having to check things before they set off and journey plan every time they want to go out in an EV. You need to get in, drive, and move along. And I have confidence in doing that today, probably because I'm a slightly early adopter, but I think we'll get consumers there generally by 2030, no problems.
Excellent, good news. How long since you drove a petrol car, Tom?
Well, my wife's still got a petrol car, so I occasionally go and do the honourable thing and help fill it up for her occasionally when she needs it. But I actually spend a lot of money on forecourts in the shop still. So as you probably saw recently from BP, the majority of BP customers now on the forecourt are actually non-fuel customers. So the majority of people walking through the doors in a BP shop on the forecourt don't buy fuel; they're buying stuff in the shop. So plenty of life in forecourts yet too.
Paul, any thanks very much for that. But any burning questions? I guess we need to wrap up. I see Andrew appearing on the screen.
Steve, Tom has been pretty active replying to a lot of them. And I think, Tim and Dave and Tom's questions have really answered the vast majority. Apologies if we haven't got to answered everybody's question to everybody's satisfaction. There's been a lot of questions, which is great. We love that. But we've got to hand over to Andrew to close off.
Can I just say that first, thank you to our experts. I mean, you guys are blinding. I wish I could sort of catch you every day. And thanks a lot. It's been great.
Our pleasure, Steve. And I can't speak for the others, but certainly, we live in a lovely connected world now. So if there are any questions that anyone wants to ask me independently, I'm sure you can track me down on LinkedIn very easily as well.
Thanks, Tom. That's a great offer. It just falls to me, really, on behalf of the IMechE AD, to thank all of our speakers and presenters today. I've found it, as someone who's working in this space now and having at least professionally transitioned from the ICE world into the alternative fuels world. My personal vehicle fleet hasn't made the jump yet, but that's a work in progress. But yeah, really interesting to hear the different perspectives from our speakers, all conveyed with extremely good clarity and rationale, which I thought was excellent. A really outstanding, engineering and economic discussion. Lots of different facets talked on. So, Steve, thank you so much for chairing it. It's great to meet you again, and I hope there'll be future opportunities. Dave, Paul, Tim, and Tom, also outstanding. Really appreciate your time and excellent perspective. And I think the key thing that came across to me as a practicing engineer is, don't rule out any possibilities. Technology is evolving. All of these different technologies will have positions in the future. I think it was Tom made the point about even now the whole series of different energy vectors are utilized in the distribution of people and products, and we should reflect on that before closing our minds to any of the alternatives that are available now, or indeed any of the ones that come up in the future. So yeah, final thank you very much. Thanks to all our audience for participating and posing the questions, and for the HQ team for holding the event today. Thank you.
Bye-bye.
Thank you very much.
That's great.